Hello everybody, this is Sonam and today I would be demonstrating a composite design pattern. So I would be covering its intent, motivation, structure. I would give a demo and discuss the consequences and uses. So to begin with, a composite design pattern falls under the category of a structural pattern, and structural patterns are basically concerned with how different classes and different objects they are grouped in order to form a large structure. And in a composite design pattern, we create a complex structure only out of two classes. One is called leaf and the other is an object. So you use principles of polymorphism, inheritance, and recursive composition to form a complex structure out of these two components. The intent. So composite pattern has two intentions basically. One is to form a tree structure out of a leaf and a composite, and the second one is to treat both the leaf and the composite as a uniform structure to not distinguish between their implementation. Motivation. So basically, a composite design pattern is needed when you have a tree data structure and it has got leaf and parent nodes. Your leaf and parent nodes, they perform some common operations, and in the absence of a composite design pattern, you would have to write different methods for a leaf node and different methods for a parent node, and this would lead to a very complicated solution from the maintenance point of view. So just to give an example, a file system can be considered as a tree data structure. So there are leaf nodes like a text file or a PPT file, and and the folder is a parent node. So if these common operations such as create, move, delete, if these are not grouped together, it would lead to very messy code, and it would not be a good decision from the maintenance point of view. So that is how composite design pattern came into picture. This is the structure of a composite design pattern. As you can see, you have a composite and a leaf. So the leaf is like an atomic structure. You cannot divide it further. And a composite structure consists of different composites or different leaves. And also these composites can in turn add different composites, and they can even add different leaves. So you can keep on multiplying the composites to form a huge structure. Okay, so in order to code a composite design pattern, you need these four components. The first one is an interface. So in the interface, you define common methods used by both the classes. The second one is called as the leaf class. The leaf class implements the methods in the interface. The third is called as a composite class. So this composite class basically stores its own leaf class or additional composite classes, and they may even have some additional functionality such as add leaves, add or delete composites, leaves, etc. And finally, you have one client class. So this client class is basically used to it is used to manipulate the objects in the composite. So now I would be demoing an organization chart. So I have created a similar organization chart using a composite design pattern. So as you can see, the organization consists of a CEO. There are two managers. There's one accountant and HR, and there are three engineers who report to the engineering manager, and there's one sales engineer who reports to the sales manager. So obviously the CEO, the engineering manager, and the sales manager, these are the composite nodes because they have leaves or composites connected to them. And the other people, the rest of the engineers, the accountant, they are all called leaf nodes because they cannot be expanded any further. This is the UML diagram of my application. As you can see, there's one interface called employee. So this employee interface has got the common methods which any person in the organization would implement. The first one is print info. So when you run print info, you print out all your information like your name, your designation, and to whom you report. The second one is get subordinates. So if you have any, you get a list of the subordinates. And some other methods like get designation, get name, etc. So the next class is called the leaf class, wherein each employee or each leaf has his name, employee ID, designation, and which designation he reports to. And finally, you have this composite class, where again the methods there are common methods between the leaf class and the composite class, as you can see, but there are these three additional methods called hire, fire, and replace. So a composite can hire the composite manager or the CEO. They can hire people, they can fire people, and replace method is is one extra method I wrote so that you can replace the people who are fired. And lastly, this builder swing class is like a client class. It initializes the GUI, and it is used to create this entire composite structure using hire, fire, etc. methods. So let me start with the demo of this. So the first, as I said, this is the employee interface, and these are the methods of employee interface. This is a leaf class, wherein each employee has his name, employee ID, designation, and reports to whom. And these are the getter and setter methods. So you have a similar structure in the composite class as well. Each composite employee has his name, ID, designation, reports to. And very important, there is this array list called subordinates. So for example, if a manager has got 4 subordinates, so those 4 subordinates would be stored in this array list. And there are these three extra methods which only a composite has. One is hire, the second is fire, and the third is replace. So I'll explain these in the demo. And lastly, you have this builder swing Java class. This is like a client class. I have initialized the components of the GUI over here. So these are all the GUI components. I have created composite objects as well as leaf objects. As you can see, this is the creation of one composite object, and this is the creation of a leaf object. So I have created the composites and the leaves, and finally I have created this entire composite structure, where one composite CEO hires engineering manager. The engineering manager in turn hires different engineers. So this is how you have created your leaf structure. And lastly, if you run this print info method, if you run the print info method on the CEO using the principle of recursive, there's this principle of recursive composition, that if you run one method on the composite will in turn call that same method on its children. They in turn will call that method on its children, and in this way the entire structure, the entire tree structure will get printed out. So let me just run this first. Okay, so this is how the organization looks. This is there's a CEO. Her name is Kate. There are additional employees. There's one engineering manager. 3 people report to him. There's one sales manager, and there's one accountant and one HR. So if you want to see the same thing on the console, these are the print info details. There's a CEO. You have Dirk, who's the engineering manager, who reports to her. There are these 3 people working under Dirk: John, Thomas, Richard. These 3. You have Brad, who's the HR. You have Tom, who's the accountant. You have the sales manager, Mary, and these 2 people who report to Mary, Joe and Anne. So so basically this is the composite structure that I have created, and you can even manipulate this. So for example, if I want to fire somebody, so the minute I click on remove, a mouse click event will be generated. Um a mouse click event will be generated, and it will call the appropriate fire method. So for example, if I fire Tom, so this fire method will be invoked, and the object of Tom will get passed here. And finally, this piece of code, the subordinates is an array list, and you happen to remove that object from the subordinates array list. This is what happens basically. So I'm just removing Tom. There's a vacancy that gets created here. At the same time, our list gets updated. You will not find Tom in this list. Okay, so this is one method. And at the same time, if you want to fire a composite, it can get a little tricky, because if you fire a composite, these three leaves who the composite consists of these three leaves, right? So even these three leaves will get fired. So so I did a small tweak in the program. I wanted to, if I want to fire only the engineering manager, so this is what I do. I call this function, and composite. So basically, my written code says that if the employee whom you want to fire, if he has subordinates, they get stored in a temporary array list, and from there they get assigned to the CEO, and only that particular employee gets fired. So there's an addition, this message gets updated that these three guys are reporting to the CEO now. And coming to the replace method, if I want to replace, if I want to I fired Dirk, right? So if I want to replace Dirk with somebody else, suppose I hire Anna in place of Dirk. I enter her name and her designation, and as the minute I hire her, in the composite, the replace method is invoked. A composite object gets created, and a composite object gets created. It gets assigned to our composite data structure, and after this, two things happen. So over here we search for the employees who were reporting to the CEO. Those three engineers, they get relinked back to the engineering manager. So you can see here the reports to CEO is gone, and these three guys again report to the engineering manager, as well as the CEO removes them from his list of employees. Basically, that's what happens. So and if you want to view the console, so this is the latest print info method on the console. So you have Kate, you have Brad, you have Mary, you have two people reporting to Mary, Joe and Anne. You have this engineering manager Anna, and you have these three guys, John, Thomas and Richard, reporting to Anna. This is how the organization looks like. You can even fire or hire random people, and accordingly the changes will take place. So back to the presentation. Known uses of this design pattern are, So there are there are graphics Java library, there are Java graphics libraries called Swing or AWT. These libraries basically follow composite pattern. The components, like for example a text box or a combo box, these are considered as leaves, and these when grouped together they form a large composite object. Any file system also is an example of composite design pattern. And lastly, any object that has a tree structure and parent child nodes, for example the employee organization that I just showed, it can be treated as a composite design pattern. Consequences of this pattern are: it makes the client simple, because clients do not know if they are dealing with leaves or composites, and that simplifies the client code a lot. Secondly, it makes it scalable, because you can add new classes, you can add new leaves, you can add new composites. It does not affect your existing code structure, and this is a very good benefit because it leads to loose coupling between your new classes and your existing structure. But there is one small disadvantage, that it makes the design very general. So for example, if you want to add a new class and it has some special functionality, you can it's not a good idea to implement a composite pattern, because in a composite pattern all the classes, whether they are leaf or a composite, they should conform to the same kind of design. So that is one small trade-off. Yeah, so that's it from my side, and these are the references that I used to create this pattern. And yeah, thank you so much for seeing the presentation.